All right, let's continue talking about testing. I'm going to go ahead and share my screen. And can everyone see this test that we were looking at before?
Yeah.
Awesome, thank you. Wrong one. Okay, I'm not even going to apologize. I was trying to move the Zoom window. Can someone maybe just walk us through again what this test is doing and what each piece is doing?
I can try and explain it.
Yeah, Michael, that'd be awesome. Thank you.
So at the first line where it says describe, so it's describing which, like, kind of giving like a name to what you're trying to do. So like math max is like the description of this test. And then in the next line is saying that it's kind of giving like what it should do. So it should return the largest number. Then it runs the function that you want to run. And then the expect line is saying what the expected outcome should be. So if the function runs and like the returns the same value as what the expected output should be, it should return true. And if it fails, it should tell you like, hey, for the math.max test, it should return the largest number, but this is what it returned and this is what it should be.
Yeah, exactly. Thank you. That was a great walkthrough. And just to show that example, we run our math.max function with inputs of 1 and 20. The biggest number is 20. 20 is not equal to 5. So this expect is going to return false, basically. And that's what causes our test to fail here. Yeah, thank you, man. And I'm going to scaffold this out a bit and then maybe get a little help in writing out some more tests. So the convention is a lot of the times, like in the describe block or in the it block, we want the name of the function or class that we're testing. So in this case, we're testing this JavaScript built-in function math.max. Again, we're just using that as an example, but so we're using that as the name for this describe block. And we can have nested describe blocks. The describe blocks are really more for organization. We do have to have all of our it blocks. And I'm just using a block as kind of a general term to refer to this whole thing here. Technically, this is a function we've imported, and it's taking these two arguments, a string and an arrow function. But it's kind of its own unit, and so we call it a block. I don't think you can nest it blocks because that's like a specific test, but the describe blocks are more for kind of like ordering and setup. And so something you'll see really commonly is, let's think about the different kinds of inputs we can have for our function. And we can have valid inputs, which with math.max basically means integers, I think, maybe decimals, right? We could imagine a scenario maybe dealing with money or dealing with people's age. Age would be a great example of where like an integer, like handle user age function or something like that. An integer is a valid input, but if somehow like a decimal number got in there, like 17.5, we probably don't want that to be a valid input.
Hey, Adam.
Yes, Alicia.
Real quick, I know that you were showing when you put 20 in there, you were showing us that to like purposely fail the test, I guess. But when you're writing these, you do want to put like what you want it to be in the to be function, right?
That's a really good question. You yes, you want to put what you want it to be. When I am writing a test for the first time, I always on purpose will put something wrong and run my test to make sure that the test fails, because especially as you start writing tests for like real parts of your application, sometimes like it can be easy to make a mistake in writing the test, right? Or maybe I just made an incorrect assumption along the way. So that extra step of just like, once you write the test, then you have what it should be, and that's working. Stick some bad data in there, just change it, make sure it fails, and then change it back. That's something that a senior engineer taught me on the job, and that I found really useful. The other thing is that, like, sometimes we might write a test where we're expecting something to fail. Like, we wouldn't need to write this test, but we should not return the smallest number. And actually, this is a good one to write. You know, with math.max, this is probably overkill, but if a function's behavior was more complex, maybe we actually need to write a test to confirm that our negative, it's not really happy, unhappy, but that our negative case isn't happening. And let me change this back before I forget. And let's just use the same inputs to keep life simple. And I could say to not, let's see. Let's see, I know there's a to not be. Let me do a quick Google here and figure that out. Let's see if that works. So this does demonstrate, like, these assertion libraries give you a bunch of different tools. Like, to be is sort of a shorthand. Like we could, like, I think less than is an option. So we can write more sophisticated assertions. But I think that would work. Apologies. Let's see what happens. So it didn't like that. To not be is not a function. Maybe equal. There we go. So that's just one of the quirks of the assertion library. Like, it has this, it has a bunch of sort of methods or functions that you can chain to kind of build up a sort of bit of readable logic. Sometimes it's easier to just test for like a Boolean value. But so this is just an example of a test where we want to make sure that our output is not something. Does that make sense to folks?
Yes.
Yeah, it's a good question. Thank you. And again, this particular test is probably overkill. What I want to talk about a bit is writing tests and kind of thinking about, all right, I've got my valid inputs and I've got my invalid inputs. And again, this example's pretty small, but I hope it illustrates the point. So just what's something that, like, is probably not going to work with math.max, that if we threw it in there, it would throw an error or something?
Like a string?
Yeah. So I'm just going to put the math.max right in there. JavaScript can be a little weird with strings. If I put the actual value of 7 in here, JavaScript might actually parse that into an integer, which is not a good JavaScript feature. So that's why I'm putting those in there. JavaScript has a built-in primitive type called not a number, which you don't see very often, but that's what NaN stands for. And it is anything that's not a number. For example, again, just running Node to have, to be able to run a couple JS things in the terminal here real quick. If I compare 7 to the not a number type, it's false because 7 is a number. If I compare null to not a number, I would have actually expected that to be true. I'm not going to lie. I guess, oh, yeah, so I take that back. I got confused. We might need to revise this. I'm going to be honest. I don't use not a number that often. It is, it has some weird JavaScript quirks. And I think the reason that we're using it here is probably because that's what this built-in behavior returns with bad inputs. And actually, let's find that out real quick. We can do that. Let's do math.max ABC, ABC, and it returns not a number. So this is essentially the case that we're testing for. If I do 7 and 4, yeah, so this is a bit of a digression, but this is also an example of why testing is so important for JavaScript, because it's a language with so many gotchas. JavaScript will parse the string character 7 into an integer, and it does that here, which is just a recipe for disaster and an unfortunate feature of the language. So I apologize for the digression there. I want to run these tests that we just wrote. They're all passing. This is telling us that this function is returning our failure case for an invalid input. I think what's a bit more interesting is to talk specifically with math.max to talk about valid inputs and the happy path. Like, what's another valid input, a kind of valid input for this math.max function? Like, how can we break down numbers into some more categories?
Negative.
One example would be, sorry, go ahead.
Negative numbers?
Yeah, exactly. That's what I was going to say. Thank you. Yeah, whenever you're talking about categories of input with numbers, thinking about negative numbers is always a good one. And on whiteboarding problems, that's always a good like potential edge case or gotcha to be mindful of, negative numbers and 0. And note how, because each of these it blocks has an arrow function, like everything in here is kind of self-contained. Like nothing I declare as a variable here or do here will be used in the next it block, and the test runner does a little cleanup to do that as well. So I would expect -3 to be the bigger number here. A cool little thing you can do is you can do it dot only, and it will only run this test inside this describe block. Let's see what that looks like. So here it tells us it just ran one test and it skipped 3 other ones. And again, I have to Google the specific command line flag, but there's something that we can pass when we run VI test to print out each test message, which I personally like doing.
Would you only do the it dot only if you're like actively testing the test so that you're not running like 30 other
Exactly.
tests? Okay.
Yeah, good question. Exactly. Yeah. You can also do describe dot only to run a whole block. Let me see if I can get this, because I really would like to have that printed out. These test runners often have like a whole bunch of configuration options. Often there's like a verbose method. I apologize. I will find this and circle back to people, because that is always nice to have. But here, when we run the test, it tells us that it runs 3 and skipped 1. And so it's skipping this describe block here because we have this dot only. And Alicia, that's exactly like what you're saying. Like when you're writing tests or working on a particular part of code, that's just sort of a utility function to help the developer. So that's really the main thing with unit tests. I think the one thing I do want to talk about a bit more with unit tests is that, let's see here, how to write a unit test, types of testing. Yeah, and this really should be its own category. So with unit tests, with all testing really, sometimes you have to refactor your code to rewrite a bit of code to make testing possible with unit tests. And this is a little bit of a contrived example, so bear with me. Kind of related to this, sometimes you have to mock certain functions. Like a database call. The reason we have to do this is to improve the performance of our test, the speed, for consistency in our test, or because the test is running in a different environment. So we might have to fake database calls. Maybe we have to do this because maybe a DB call takes a long time and slows down the tests. Maybe we want to make sure we always use the same data for our test. And for and companies that have, especially for consumer facing products, there will often be a whole test environment with the test database, but sometimes you might just want to fake a function And finally, maybe we want to be able to run our tests in an environment where the database doesn't exist, common with larger infrastructures. So like, if we, again, like Nordstrom's, for example, maybe they have like a really big database of real data, and it's real customer data, and maybe it has sensitive information, and it's just difficult to access that database from our development environment or like on my laptop. So maybe we just want to like write a function to fake making a database call entirely. Does that kind of make sense to folks, and do folks have any questions around that? Okay, cool. So the other things we'll fake would be HTTP requests. And sometimes for front-end testing, we have to fake the browser. For example, get cookie or get CSRF token. Like if we have some React code that depends on things that the browser gives us, we might have to fake it. And actually, like DOM functions such as window.reload, so window.reload, let's find a good one. Window location href, that's a good one. And in the curriculum for today, and I think what I'll do is I'll just share this on my screen and talk about it briefly, because I don't have a test we can run that uses it. Here's an example of this, of writing a function to fake getting a CSRF token. And just to kind of break this down, this is the real magic of the function, is that it takes a string as an argument. And this function doesn't care where we get this cookie string from. So when I use this function in code running in my browser, I can get that cookie from like the actual browser using, you know, it's like, what is it, window.cookies, or however you access the cookies. But when I run this function in my tests, I can pass in a string some other way. And there are certain things we can do, like we haven't really talked about environment flags. But this is a common way of doing this, is that like this is a great package. Let me go here and just kind of show an example, and I'll share this in the chat. Like often we will create, I think we've talked a bit about creating a .env file. So what would be very common is to have like a .env.dev file. And we can use that to set an environment for dev or production. And JavaScript and Node gives us a couple ways to look at those environment variables. The long and the short of it is we can have an if statement in our code that says, hey, if I'm really running in a production environment in the browser, get the cookie this way. If I'm running in a development or test environment, get the cookie this other way. So that's kind of the main thing there. And again, I just kind of wanted to touch on this a bit. That would be maybe like a great lightning demo if someone wants to implement using environment variables for parts of their personal or group project, or I can talk about that more with folks who are interested. But again, the essence here is this software development concept of kind of separation of concerns. Like we've now broken down getting this CSRF token into 2 tasks. The first task that we don't talk about here is how do I get this cookie string to begin with? And that's where we can do it in different ways, depending on if we're running our code in a test or in the browser for real. And once we get the string, then it's just a bunch of string manipulation logic, essentially, to grab the bit of the cookie that we're interested in with the CSRF token. So I know I kind of glossed over a lot of the implementation there, but I just want to check in with folks to see if that basic idea of sort of refactoring some code to make tests easier and having some separation in our code so that our code can still run in a test environment, if that kind of makes sense to people. Okay, cool. And we can chat about this more too, one-on-one for people who are interested. Let's see. Let's take a 10-minute break because there is a bit more ground to cover, but this is the exciting part where we're actually going to like have our tests open and run a browser. So rather than just dive into it, let's take a 10-minute break. And then when we come back, we can be refreshed, power through it and call it at noon. How does that sound to people? Okay, awesome. Thank you very much. So let's call it like 11:25. So take 10 minutes, plus change. Just have your eye on Slack in 10, and I'll see everyone soon.